Good afternoon. Today I'm going to talk about how we can take Gerber data exported from either ADS or AWR and convert it into an Ansoft Neutral File, which can then be imported into Ansoft Designer and HFSS. We start by collecting our conductor Gerber layers and our drills or vias into a directory, and we create two temporary directories, an output and a working, and then we load the metal layers in order that they appear in the stack-up. Now we load our via layers as drills. And now we tell the program what layers they go between. The first one goes from 1 to 3, because these are stack-ups. The second one goes from 3 to 5, then from 5 to 7, then 7 to 9, then 9 to 11, and finally 11 to 13. We're also able to set the dielectric properties and thicknesses of the layers using the properties dialog. I'll grab all the metals first, and then I'll set their thickness to say 0005, half a mil. Let's say they're gold, and we'll set a nice golden color and click modify. And now we'll do the same thing with the dielectrics, and we'll set their thickness to 005. Say alumina, and give it a different color. And this information will be passed along to the ANF file and can be loaded then by the Ansys applications. For our preferences, we will make sure we use circularize, because this will give us clean circles or clean arcs in our output format, and Leonov. And for our output, we'll select ANF, give ourselves an output file name. That's all we need to do. We save our parameters, and now the program will run. It runs very quickly for a small file like this. And if you look in the output directory, you'll see that we created an ANF file. We've also created a comp file, but there's no components, so it's empty, no pins, and there's our settings so we can repeat our work later. We'll now load the ANF file into an Ansys application and show the results. Alright, now we're going to test our ANF file by loading it into SIWave. And there's the file we just created. Generates nets, but that doesn't seem to be very valuable here. And here you can see the file we created. I'm going to move the grid and I'm going to zoom in so we can see better. And what you can see now is that we took all of the overlapping flashes and traces and entities, and we've created nice clean boundaries. You can also see that we have arcs wherever arcs are appropriate. Here at the two pads we have arcs, and you can also see that we generated vias wherever there was the via drill layer, and they're actually intelligent vias. They have pad stacks associated with them. So we get a very clean output that will be very meshable by the HFSS simulator. It won't generate unnecessary triangles in the mesh because of little segments or little pieces. It'll be able to optimize its mesh. The other thing you'll see is that the dielectric information that we put into NETEX-G also gets passed to the stack-up, so the user does not have to re-enter this information a second time. We can pass the thicknesses, the materials, and the electrical parameters. To summarize, by using Gerber data, we make our solution independent of whatever layout tool you choose to use. Second of all, the NETEX-G runs fully automatic, and there's no need for user intervention or expertise other than to load the data in the right order. And finally, we produce a ANF file, which is native to the Ansys and Ansoft environment. It includes the stack-up, it includes the layers, the vias, and net information in pad stacks. So we think it's a very good solution for what TriQuint is trying to do.